Okay, so cell membranes and transport, chapter 5. Let's start off by copying down some root words. Some of these, I'm sure you already know. Some of them are going to be new to you, so take the time to write them down. It's going to be important that in the next 2 or 3 days, before the end of the week, certainly, you know these root words because it's going to really help the chapter make better sense. In this chapter, there's going to be a lot of processes, and a lot of these processes will be named from the list of root words. For example, one of the processes that can happen to a cell is called cytolysis. If you look at the prefixes and suffixes, you'll know that means the cell is loosening or splitting. Cytolysis is actually when the cell completely explodes. So I'd call that a cell splitting if a cell explodes apart. Words like endocytosis and exocytosis are processes you're going to need to know. Well, endo means within and cyte means cell. So endocytosis means something going within the cell. Exocytosis means outside the cell. So exocytosis is going to be something going outside the cell. There's also a process called phagocytosis. If you look at the root words, that's going to mean something going on where the cell is feeding or eating. So this is definitely one of those chapters where the quicker you take the time to memorize the root words, the more it's going to help you. Okay, I'll give you a few more seconds. All right, so here's the first thing you're going to do with your group. Real quick with your group, you're going to scoot your desk if you need to, but hopefully you can talk to your group from where you're sitting and review what the term homeostasis means. In your notes for this chapter, every person needs to agree and write down a definition. That should be quick, should take less than a minute to do. Then what you need to do is relate that term to cells and explain to your group and write down in your notes a sentence or two about what a cell is going to have to do to maintain homeostasis. So turn to your group. You have about 3 minutes to accomplish this. Okay, at this point you should have a definition for homeostasis written down, and you should be having the discussion or already writing down what cells need to do to maintain homeostasis. You, for example, need to maintain a constant temperature. Your body needs to maintain a pH, different in your stomach, your intestines, your blood. What kind of things are the cells working to maintain? Write that down. What things do cells need to keep the same? Talk to your group. Come up with some ideas. Okay, I'll give you about 30 more seconds. You should have at least 4 things that the cells have to maintain. Might be a little more specific on bad stuff. Germs, bacteria, yeah. Okay, so let's come back as a whole group. So you should have reviewed a definition for homeostasis. Something along the lines of maintaining an internal balance. But homeostasis can be maintained at all the levels of organization. So in this chapter, we're going to look at what kind of balance do cells have to maintain. So raise your hand, just give me one of the things your group came up with. What does a cell have to maintain?
Like a certain amount of water.
Good, has to keep the right amount of water. What else?
Energy consumption and production.
Okay, so they have to balance the amount of energy they're producing and using. Good, what else? What other things would you not want to be too high or too low in a cell? Levels of what? Could be things that are the same as your body too. Brenna? pH, yeah, your cell's pH has to be the same. What else is it going to want to regulate? Maybe not allow in or out. Yeah.
Viruses and germs.
Yeah, it's going to want to make sure it keeps the bacteria and the germs out. The right amount out, the right amount in. Good. All right, so let's talk about some of these terms and some of these ideas. So we know that organisms have to maintain and adjust constantly in order to survive. We get that in our bodies. I think because it happens to us all the time. If you get too cold, your body shivers. It's a feedback loop. It warms your body up. If you get too hot, your body sweats. It's a feedback loop. It cools your body down. We have to get in our minds, though, that this is also going to happen in cells. That cells will have processes going on to keep all the correct levels, to keep all the correct balances for the single cell. Okay, so homeostasis is not something that just occurs at the organism level. It occurs at all the levels of organization. And for a cell, really what it comes down to is the environment. The cell, most cells don't have flagella. In fact, in your body, there's only a few types of cells that have the ability to actually swim and move. Most cells are kind of stuck where they are. So what the cell has to do is maintain a balance within whatever limits of the environment it's in. This also makes sense if you start thinking about little organisms that swim around in like pond water. There's going to be certain things they can tolerate and certain things they can't. If I take some small bacteria or small microorganisms from a pond and try to put them in ocean water, like salty water, they're probably going to die instantly because it's just going to be beyond the limits of what they can tolerate. So cells do have limits, and it really depends on what happens in the environment and the cell reacting to what happens in the environment. There's several terms here, several reasons why materials are going to move in and out of a cell. So we're going to start with the simplest idea. Molecules are always in motion. This is called Brownian motion. You probably have known this idea. It comes up in earlier science classes that molecules don't stand still. If molecules were to stand still, do you know what temperature they'd have to be at for a molecule to actually stop moving completely? Absolute zero, yeah. Really, really cold temperatures. So molecules are always moving. And when they're moving, they're going through a process called diffusion. Molecules move from areas of high concentration to areas of low concentration. Because they're always moving, they're going to spread out from highly concentrated areas to low concentrated areas. And this is something you've experienced. Maybe in the locker room after PE. If someone decides that, hey, I kind of smell a little bit today, I'm going to use some of my Axe body spray to mask that odor, and they spray a whole bunch of Axe body spray, everyone that's standing right next to that person is going to smell the Axe body spray right away. But within 2 or 3 minutes, the Axe body spray is going to diffuse through the air, spread out from where it was highly concentrated to where it's less concentrated, and pretty soon the whole locker room is going to smell it. Right? So diffusion is the process of molecules moving from high areas to low areas. The reason why this happens is because when the molecules are all constantly moving, if they're in an area of high concentration, they're bouncing off of each other a lot. And they're going to eventually have so much they're bouncing off of it, they're going to move to the areas where there's more space. I've heard this described as someone dancing at a person dancing at a party where it's really crowded. If you're dancing all over the place and bumping into people, eventually you're kind of going to get pushed to the edges and you're going to spread out. Okay, so eventually what's going to happen is all the molecules are going to be spread evenly, like in this picture. So imagine I started with my Axe body spray or whatever molecule I'm talking about all down in the corner. Maybe all these molecules are all in the corner, but eventually they'll spread out fairly evenly across the area. Okay. Diffusion is one of the major ways that things are transported in cells. Cells don't have arms, cells don't have legs, cells don't have little conveyor belts. Cells can't, say, oh, well, it's time to bring some water in. We're going to go bring the little cart out there and fill it up. And cells can't do that. So this is one of the major ways that cells rely on moving things in and out. It's just by diffusion. Things will go from where there's a lot to where there's a little. Now, because this is happening in and around cells, we get something called a concentration gradient. Concentration gradient only occurs when you have a membrane. So it's the difference in concentration on both sides of the membrane. Do you have a higher concentration inside the cell, or do you have a higher concentration outside the cell? That's called a concentration gradient. Now, there's going to be some factors that are going to affect how quickly things are going to diffuse into a cell, out of a cell, in a room. So let's go back to my Axe body cologne example. I'm going to spray some Axe body spray in the front of the classroom, and I want you guys to smell it as quickly as possible. What can I do to make you smell it faster? Well, okay, that's true. Completely true. If I turned a fan on, it would push the molecules faster, but I want it to just happen from the molecules themselves. I could spray more. All right, let's write that down. I could increase the concentration. One way to make diffusion happen faster is to increase the concentration. Okay, there's two more ways that I could increase. Now, the concentration is the easiest one. Now we got to think a little bit outside the box. What's something that makes molecules move faster? What would make a molecule move to your nose faster?
Add more energy.
How? How do I add more energy? Heat. Yeah, increase the temperature. Exactly. So increasing temperature, which is really the only way I can increase the energy put into that, is another way. So I can increase diffusion, the rate of diffusion, by increasing the temperature and increasing the concentration. Now there's one more way, and for us, because we live at a pretty low elevation, we don't think about this very often. But if we lived in like Colorado at a very high elevation, we would think about the third thing that we could do to increase the rate of diffusion. Have you ever like baked cookies or baked a cake, and at the back when you're reading the directions in the box it says, if you're at a higher elevation, add more time? Have you ever seen that? If you go to Colorado and because Colorado is very elevated in most of the major cities, you boil water, it takes a lot longer for water to boil because there's less what? There is less oxygen. Okay,